Hello there, and welcome to ClueCon Weekly. Every ClueCon Weekly is a good one, and this one's an especially good one because we've got Jim Dalton with us from TransNexus. Hi, Jim. How are you doing?
David, I'm doing great, and it's my pleasure to be here, and it's great to speak to you.
It's a pleasure to have you on, Jim. I feel it's like I've known you a good few years, meeting you at various IT expos and other events around the place. Even Astricons. Have you been to an Astricon at all?
Oh yeah, David. Yeah, we've seen each other at so many shows going way back. It's you've been a pioneer from the very beginning, and I think it's been the whole time.
You're very kind, Jim. It's always been good to hang out with you. And at the last show, the one in Fort Lauderdale that just went, IT Expo, where we ran the open source world track, I was hoping to bump into you. And I did actually see you walk past the door of the room where I was chairing the conference, but I didn't get a chance to actually speak to you face to face. So now we get to do that.
So, well, great. And I tell you, it's great to be, doing something associated with ClueCon and Free Switch, because this community, it's always led all the innovation in the voice over IP space. So it's great to be chatting with you, David, and be slightly part of this community. It's terrific. Thank you.
Oh, well, we're pleased to have you along. Now, I think this is your very first ClueCon Weekly, Jim. So I wonder if you'd mind just telling us a little bit about how you got to be where you are today in terms of your career and your exposure to different technologies, and then finish up with a little bit about what you do in TransNexus and what TransNexus does before we move on.
Okay, sure. Yeah, so going way back, I started at BellSouth. So I'm a telephone guy from the very beginning. And at BellSouth, which is a traditional RBOC telephone company, I worked in mobile data and got to learn about the data business there, and saw that, voice over IP was going to make a lot of sense. And so really in 1997, we started TransNexus to sell routing software for voice over IP operators. And we've been doing that ever since. We still have the same platform. We continue to expand it and improve it. We have an on-premise platform and also a cloud solution. And part of our routing policy platform, it's a really good fit for a new technology coming out called Shaken that we're going to talk about today. And that's the focus of what we've been doing for the last year. There was a law passed in the U.S. that requires every telephone service provider to start digitally signing their calls using this Shaken technology framework. So should put an end to spoofed calling numbers. And we think it's big. We think it's the biggest thing for voice over IP since SIP. If you can get back to trusting a telephone call, that's big. I think that's really big. And there's a lot of, when you have that infrastructure there that you really can trust the call source, there's, I think, innovators like the Free Switch community and ClueCon, and those folks are going to find a lot of really new, interesting applications that are going to be enabled by that basic fundamental that you can trust a phone call where you can't trust other forms of communication over the internet. So we're excited about it.
I guess this was part of a sort of democratization of the technology, because when you think back to ISDN, it was the people that owned the ISDN that made the rules about what you could do with caller ID or not. And the rules were pretty much, you can only send the one number unless you've bought lots of DIDs, in which case you might be allowed to send one of those DIDs. But that was pretty much it, wasn't it?
That's right.
And then, that's really because we were in an era where it was like a dumb endpoint connected to a very intelligent network called the PSTN. Now, of course, we have a lot of intelligent endpoints that are all running SIP stacks and stuff like that, and they connect to a dumb network called the internet that just kind of carries the stuff that you squirt into it. And so the power has been put into the kind of the owner of the endpoint, and there's a lot of people doing a lot of nefarious activities with caller ID. So yeah, this new technology, I hope, is going to have a positive impact on that situation.
Yeah, I think it will. I think it will, and it's going to be we're excited about it, and I'm happy to tell you about what we're doing and what the industry's doing. David, if you want me to get started with that.
Yeah, that'd be great. So if you want to flick over onto that, I will bring your presentation up because it'd be great to hear about that. I'm going to press the appropriate button now, and there we go. I've got a picture of you in my top right corner, Jim, and your presentation is there. So please take it away, and I'll be listening, and I may interrupt with the odd question or comment here or there.
Well, that would be great. Yeah, speak up anytime. So this is all about shaking. If anybody's not familiar with it, just a brief bit of background. The FTC, and the FCC in the U.S., I mean, they just get hundreds of thousands of complaints literally every year about robocalls. And for years, they've been trying to find a solution and really have been driving the industry to develop a framework to restore trust in the public telephone network. And it leverages a IETF-defined standard called Secure Telephony Identification. And it's really just digitally signing a token in the source of a call source of a network, that so you can trust the calling number. And so we'll go through all of those details. And let me start with this. This is important. This is, it's really makes it real here. It's an act of Congress. It's going to force people to implement this technology. And, there really was, the technology works. It's not that hard, but nobody wants to do it because there's no payback for the first guy to do it. So they had to pass a law in Congress, which was signed right at the end of December. So 18 months, the expectation by the folks in Washington is that every voice service provider will have implemented the stir, shake, and authentication framework for their voice over IP networks. And what about everybody
Jim,
else? Yeah.
Let me just ask you a question there. And so TransNexus, you said you'd been invested in a year of your time in this. So would you be like an early adopter or early implementer of this technology?
Absolutely. Yeah, we sure are. We made it available for our customers. We first implemented it in December or November of October 2018. Demoed it at SIPNOC. Everybody said that's interesting, but nobody cared. We started rolling it out to our installed base in May of last year, which was good for calls just between our customers. But that doesn't really have an impact. It's got to be with every network, and that's what this law is all about. It makes it, right. It forces every network to do it. And yeah, David, I think we've been definitely an early adopter. We were actually the first certificate authority approved by the Shaken Policy Administrator. And
great stuff. Well done.
Yeah. So anyway, we've been excited about it for a long time, and I think it makes a lot of sense. And I'll just point out the bottom part of this slide points out is that everybody, even folks with non-internet protocol networks, have to implement some kind of call authentication framework. So the lawmakers are really after stopping robocalls and calling number spoofing or in all networks. And Shaken, we are finding, works not only for voice over IP networks, but also can be used in TDM networks. And I won't get into this presentation because we have limited amount of time, but we do have customers who are going to deploy and they don't have SIP interconnects. And we'll save that for another day. So why Shaken matters? And, it's more than just a regulatory burden. So it's a law in the U.S. It's a mandate in Canada as well. You've got to implement it. And so, but it's more than just a regulatory burden. Well, why it matters is enterprises they're moving a lot of their traffic away from telephones. Their way to communicate with their customers by outbound calls is just less and less effective. People don't answer the phone because they don't recognize the calling number, and they don't answer the call. And for enterprises that are trying to reach their customers for whatever reasons, legitimate reasons, their prescription is ready, school is closed, whatever it might be, they can't answer the phone. So it's a major issue for enterprises and an opportunity for service providers to be able to provide this, because a phone call is worth a lot to an enterprise if it gets answered, and Shay can help make that happen. And then for consumers, telephone service is becoming irrelevant. People just don't answer the phone unless somebody's calling that's already entered in their contact list. And that's terrible. That's a terrible situation for people who are in the business of providing telephone service. But there's also some upside that we'll have one slide. We'll talk about this that we think is cool, and I think there are going to be other applications on top of this. But this whole infrastructure of creating a digitally signed token, you can add to that token and digitally sign it so you can trust it, rich call data. and you can put the picture of the calling party, you can put the logo of the company that's calling, put the reason for a call. This is it's really interesting. This technology is being driven by a big cable company, and one of their reasons is very personal to them. They roll a truck, to call on a household for fix a cable problem. They call, I'm going to be there in 20 minutes. People don't answer because they don't recognize the number. Their view is we're going to use rich call data. It's going to be trusted because it's going to be digitally signed. It's going to show up on their TV. It's going to show up on their handset. It's going to have the picture of the technician. I'm coming to fix your cable, whatever it's going to be. And every time they prevent a wasted truck roll, that saves like $150. So it's
it's the dollars that do it, Jim. If there's dollars to be saved or made.
Yeah. So it's, and you can trust it. It's not like CNAM. CNAM, you get some bogus things in the calling number display because it's at the tail end of the telephone call, and you have to trust the databases. Here, the enterprises have control of how they want to present who is calling and really the reason for the call. That's fairly dynamic. So for service providers, they could really, there's a lot of value they could add to enable this for their enterprise customers. So we think Shaken's big. We think it matters. So let me move on and kind of get into the guts of how it works here. It all starts with this governance authority, and that is really that's a body. It's 12 companies and associations are the board members of the GA, the governance authority, and they set the policies for the FCC of, how will this trust infrastructure be implemented? What will be the policies? And they put out a contract last year that was won by iConnective to be the policy administrator. And right. iConnective, they keep a list of really two sets of people to enable, or two sets of organizations to enable this trust anchor. And the first is who can sign a telephone call. You have to be approved. It can't just be anybody. There's some minimal regulatory requirements you need to hurdle to get to that point, which aren't too onerous. You don't need to be a CLEC, but you do need to be an interconnected VoIP provider. And those regulatory hurdles are pretty low, but it is important because, it just keeps out anybody from being able to sign a telephone call. There's real accountability. And the other set of organizations they track are certificate authorities. So you just can't go sign a Shaken certificate. You could. The technology's not hard, but if you do it and you're using a certificate that's not approved by the policy administrator, that's fraud. And so they keep the list of who can sign telephone calls, what service providers, and who can issue certificates that can be used to digitally sign telephone calls. So it's really this triangle of trust that puts it all together because, it's the policy administrator keeping track of who can sign and who has infrastructure to enable signing. So that's the, it's nothing new. What's new is you've got some responsible, accountable public policy administrator that kind of keeps everybody honest. And that's how this works. That's kind of the key focus of it for the trust anchor. So let me just kind of walk through. You want to do Shaken, you want to get set up. The first thing you do is you need a key management system, and this is going to be available in FreeSwitch sometime,
Hey, Jim, can
yes.
I just interrupt you for a minute? If
Absolutely.
you look at the bottom of your screen, can you see a message that says podcastsignalwire.com is sharing your, if you can just click the hide. That's Good. Right. I just wanted people to be able to see all your screens in all their glory, or all your slides, I should say.
Thank you, David. Thank you for that. So let me go through kind of the components of what it takes to do Shaken. And, I think everything I'm going to talk about is coming in FreeSwitch. I don't know the details. I'm going to be talking about what we've implemented, but what will be available to, the open source community is going to be basically very, very similar. And really what makes it work in your soft switch is first you need a key management system, which isn't anything too complicated, but you need a way to generate a private key and go to a certificate authority to get that public-private key pair signed, and then basically get that posted to a certificate repository. So that's the key new module. That's the important new module that's going to be added to any soft switch that's going to be digitally signing. You'll have a KMS, in your soft switch or in your external application. Probably for most cases, it's going to be an external application that manages these keys, gets the certificate, and creates the private key for digitally signing calls. Straightforward. And let's see, I want to talk about. So we've talked about the setting up the key management system. You've got a private key, you've got a public certificate for that private key, you're ready to sign a call. So a call comes into your switch, and your switch is typically going to make a SIP invite call to a shaken authentication service. And this is just software. So you send a SIP invite, the SIP invite has the calling number, the called number, the timestamp for the call. And that authentication software is going to create a token and digitally sign it with the private key. And that private key is going to be passed back to the soft switch or SBC and copied into the outbound invite that goes to the destination network. So here we got an invite with a token. And let's just take a quick look at that. What is this token? This is it. It's just here it is. It's it's not base 64 encoded like it would be in a SIP identity header, but this is what you would see, the contents of it. And the middle, this line right here, that is the certificate and the address for the repository where to get the public certificate to validate this token. And some key fields I want to point out here is this attestation value, because that is an indicator of what trust level the source network has for the calling number. And really there are three levels of trust. A is, this is a trusted number. I know this is my customer. I can trust this telephone number. Attestation B means, I trust this trunk where this call comes from because, it's one of my customers, but I'm not exactly sure about the telephone number. So it's a little lower level of attestation. And then C is you have no trust. I'm a transit carrier. This call came in out of the blue. I have no trust level about this calling number, but I'm creating this token right now so it can be traced back to where this call got put onto the SIP network.
Right.
And
so
then below,
Jim,
yes,
it's incumbent on each individual carrier to populate these fields before they pass it along to the next leg, as it were.
No, just the source network.
Just the source. Right.
Yes. So the source network, he knows his customer. He can trust this calling number. I'm going to give him A. You pass it off to the transit network. Transit network just passes the token.
Right.
He should not change the token. So the rest of the token has the calling number and the calling number and the call ed number and the timestamp. And then down here at the bottom, this is what the feds are really interested in. It's got this origination ID, and that's what you can use for immediate traceback. So you know who signed the call from the digital certificate, and you go to that operator and say, hey, somebody complained about this calling number, and it's coming from this origination point in your network. That could be a calling number, source, trunk group, whatever it might be. But it's a very unambiguous way that you can immediately identify where that call is coming from. Only the originating network can decipher that origination ID, but it makes it quick for identifying the bad actors. So a token gets passed, and it's in the destination network. The terminating carrier, they get that token, and you pass that to your verification service, which is basically it's just another software module. You just forward the SIP invite. It's going to have the SIP identity header, and we'll look at that one in just a minute to see in a SIP invite what it looks like. And the verification service gets the token. And, you don't have to do this for every call. You just do it for the first time. You need your certificate, and you're going to cache that. And you're going to validate the signature of that token. And if it's based on the results of that signature validation, you're going to send back, you're going to add a verstat parameter to the P asserted ID. That's the verification status that indicates the telephone number is validated, it's not validated, or it can't be validated. And that's it in a nutshell. So Shaken doesn't really identify robocalls, but it gives you absolutely certain information in terms of the calling information, the calling number, to be able to assess in your analytics, is this a good call or not? Or, what's the riskiness based on the calling number?
Right.
So that's how.
Let me just ask a quick question there. So let's say you've got some bad guys spurting out bad calls, but the carrier is in on it, and they are putting an A, say, at the originating point, but actually it's a call that's not to be trusted, and the terminating carrier decides that it's not to be trusted. What happens? How is there any action taken against the originating carrier?
Yeah, absolutely. So a couple of things. So back to your point, the call is signed, the signature's valid, and it's attestation A, but people complain. Well, you go back to the policy administrator and say, we are getting complaints about this calling number that was signed by this carrier. And it's a guy trying to, he's doing the IRS scam. And now, there are plenty of great laws against bogus calls, but they can't be enforced. Now those laws can be enforced quickly. And that carrier, they're going to be yanked out of the policy administrator's list of carriers that can sign calls. And if the certificate authority's involved in some way, they're going to lose their ability to issue certificates. So enforcement is the key that makes this work.
So just to clarify in my mind, that the receiving party, the called party, would smell a rat and say this is a dodgy call. They could report it to their terminating carrier. The terminating carrier could talk to the policy administrator, and therefore the policy administrator could take action to stop the originating carrier being able to attest about these things.
Exactly. Yeah,
right. I'm with you.
So it's simple. They flip the switch, they revoke that originating carrier certificate, and they're out of the trust network just like that. So it's it's nothing new. This has been around for a long time, this public key infrastructure technology. So it's tried and true. It's just never really been applied to the telephone network.
Yeah.
So this is how it works in theory. And shaken was defined by, and it's clever. I'm not, I'm not giving anybody a hard time that designed it, because they put together, a lot of smart people put together a great framework, and it works really well for carriers that have a huge IMS network and they have a limited number of points of interconnect with other big IMS networks. So all the wireless carriers, you've seen an announcement, AT&T's interconnected with Verizon and with T-Mobile. And that's easy for them because, they got a big IMS network, and the tokens can flow through their points of interconnect. But for everybody else, it's a little different. Here are the challenges I want, to kind of, that our customers have faced, and we're going to talk about the solution in just a moment. But a call comes into your switch saying, we'll go through this call flow, you get a token, you send it back. First issue, will your switch or your SBC pass that token? We're finding they get blocked all over the place. You can have a modern soft switch. It does not recognize the identity token. It gets blocked, or the SBC will block it. And simple solution, we can certainly upgrade your soft switch for a fee, and that's not going to be simple or cheap, but that's the solution that you have today. And it's a problem for a lot of carriers. And you get over that. You upgrade your switch, you go through all of that, you upgrade your switch, and now you put it out on the network, and out it goes to the destination. Should be fine if the token gets across. And what we'll see is, once you put this SIP identity header into a SIP invite, it gets too big to pass an UDP packet. So unless that network end-to-end is TCP, packet fragmentation is likely, and it's a good chance those packets for that invite are going to get out of order. And when that happens, that invite's going to fail at the destination. So that's an issue we see a lot with our customers who have their SIP end to end. They've never were a telephone company. Everything they do is SIP, but either they have a UDP interconnect, or somewhere in their transit network there's a UDP transit point, and that's what happens to these. That can happen to these invites. And of course, if you have a TDM interconnection, that's the way you receive your calls. You're never going to get a token. So that's a whole different issue. But let's say you get through that part and you get to the destination. You still got the issue. Does the destination network, are they going to block the token? Have they upgraded their switch? And so that's another problem we see. And if they had, then you would go through the steps to verify the token and complete the call. So shaken is great. It absolutely works, but there are a lot of practical challenges that are really preventing people using this. And so we had, like I say, we deployed in May of last year, and our customers started hitting every one of these problems. And what we picked up on is a draft for really avoiding this problem. It's in the IETF, and is for passing the token out of band. And so we've deployed it for our customers, and we didn't know what to expect, and it's worked remarkably well. So let me just tell you how that worked. You know, the call flow comes into your soft switch, same routine. You send the SIP invite to the authentication service, and it creates the token. And it can return the token back to the soft switch to go across the public network. But it also can send that token out of band, straight to the verification service of the destination network.
Right, and that's a parallel operation. It's not head off at the same time.
I'm sorry, Dave, could you repeat that?
Yeah, just the quick question was, that's a parallel operation to trying to send the token on the originating soft switch as well, is it?
Yes.
Or are you doing it instead of?
It can be either or. So,
right.
So, you know, it makes sense to do it both ways, except our customers are afraid to send it in band because they think it's going to cause the invite to fail because somewhere in the network won't be ready. But, you know, actually, and so when we started this, said, gosh, it's going to add the post-out delay. What should we expect? And we've been pleased. You know, you can fire a token as a mini little file that you post to a destination. You can post that more quickly across the internet than you can send. You can transit multiple SIP networks with an invite, is what we found. And so when the token gets to the verification service out of band before the call, it's nice. It gives you a head start. If you need the certificate, go ahead and get it. And if you're doing CNAM, go ahead and query your CNAM database and run your analytics, because, you know, while the call might be digitally signed, you know, it's there, you know, it's a campaign call. It's from it's a legitimate number, but I'm sick of campaign calls. I want to block that or divert that call. You know, run your analytics. So when the call comes into the soft switch and gets sent to the verification service with or without the token, you've already got all that analysis done. And that token, whether it passes out of band or in band, the logic to verify that's identical. It's just absolutely the same. How that token arrives is immaterial. But if you can get a little bit faster, then you can speed things up with this kind of analysis and then respond back to the switch to complete the call. So
okay. So just looking at number 4, the assuming that the token is coming over the network, and the number 4 arrow is the soft switch going to the shaken verification green box. If that doesn't occur, the number 5 response is the same as it would have been, even if it's gone, even if the token's gone out of band.
Right. So, you know, if the token's there, out of band or in band, it gets verified, and the results are whatever they are. And, you know, if the token is not there, in band or out of band, then you get back a response. It can't be validated.
Right. So, yeah. So I'm sorry. I'm just trying to clarify this in my own mind. So, imagine if the token has not gone over the public network, and it's only gone over the green box to green box scenario. Presumably, the soft switch is not going to make the number 4 SIP request of it, or will it still try to do that?
Yep, you do that every time.
Ah, okay.
You make that for every call, with or without a token, because that's the way you would configure that. If it's going to come, you expect it to come in out of band.
Okay, understood now, Jim. Thank you for clarifying that.
Yeah, no, good question. So that's has been an important practical workaround, and so we love the idea of passing the token in band. Makes total sense. It's simple, it's elegant, and it's going to happen one of these days. But until then, this out of band is a great solution, and this will probably be used for, yeah.
Yeah, that's excellent. And of course, you've only arrived at that because you've been a pioneer and got out there and started doing it kind of ahead of the crowd.
Yeah, and so we didn't invent this. I have to say, I can't take any credit for it. We just copied what people at the IETF wrote up, and it's great. it worked great. So anyway, we can't claim any novel ownership. Just we implemented what was already thought
you
up.
can claim some great credit for implementing it ahead of the crowd, Jim, and getting the results.
Yeah, well, okay, with that. All right, well, thank you for that. So let's see what's next here. Let me just go through a few call flows. I think more details. This is what we do today. I think, this is my expectation. This is going to be replaced by a free switch module, something similar. But just so everybody has kind of an idea of what we're doing, and I think what to expect in the free switch community. Call comes into the free switch. It sends that invite, kind of like we looked at before. And when for our platform using least cost routing, we send back a 300 redirect with a list of destinations and that identity token. And we'll look at one of those in just a minute on our system, just so to clarifies everything. And then the free switch, is going to complete the call out to the destination network. It's going to copy that identity token out of the redirect into the invite that it sends to the destination.
Right.
So, I mean, it's pretty simple, really. That's authentication. If there are cases where the application, the authentication service, you have a policy that call shouldn't be routed. Maybe it looks like fraud, or maybe, you got a call coming from, the hardware store, but they're using the DID of one of my customers who's a bank. You probably don't want that call to go through. So you would block that with a 603 decline. And that's how calls get blocked, not authenticated by the authentication service, and return action to not proceed with the call. Now, for calls coming in, this is verification. Here's a call that's coming in. You may not even get to the free switch. You may just do this out of your SBC. It might be, your free switch or your soft switch. It could be done out of the free switch, and it would be the same. Where, if it's a valid number, what we do is we send back a SIP 302 with the P-asserted ID and a V prefix added to the calling name. And this function could be done here or, in any module, anywhere in the call path. We just find most of our customers do it right at the ingress point. They don't, tie up their switch with calls that are bogus if they can block them in advance. And if it's an invalid number, same sort of thing. You send back a 603 to decline. So here's a case. If it's a bogus number, you don't even let it into your network. You block it at the SBC. But this same action could be done at the switch. So anyway, just some more detail to kind of make it clear to everybody how, this works through a SIP interface. A couple of slides here. This is, I wanted to point this out because this is the future that enterprises, I think, are really excited about, where you can, in this token, so we looked at a token before, just had the calling and called number, but you can put more information, anything that's in a V card, which you use for calendars. They give you your name, your birthday, all kinds of stuff, your URL for your logo. You can put that into a JCard format, which is going to be part of this JSON format for shaken tokens. So, and you sign it. So here you get messages, this number's been, this rich call data with the logo of who's calling and the picture and the number, anything you want to put into it can be displayed on your smartphone, and you can trust it. That's big.
Looks good.
Yeah, that's what people are excited about. So it's not going to be here this year, but I think, you can expect that probably next year, and it's an opportunity for everybody that's in the business. So let's see, David, I thought, we can take a look at a few messages if they're interested, or we can just go straight to questions and answers. What would be best for you and your audience?
You go ahead, Jim, with what you were suggesting before I may raise a couple of questions with you.
Okay, so you want to look at just some messages? Is that what you're? Is that
yeah,
what you
let's
said?
do that.
Yeah, let's just. It's kind of instructive, I think. So I'm logging into our application. This could be, anybody's application, and let's just look to see. It helps me sometimes to look at, the SIP details.
Yeah.
So let's see. So here's a call that's come in, and this is we'll look at this. Here we have, let's see, this one doesn't have a token. I will need to get a different message. Just a minute. Let's try this. Let's see. No, hang on just a minute. I think try one more call. Okay, this is what I want. So here's a SIP invite that's coming into the verification service. So it's just a plain old invite. And it goes into the authentication service. So this will be coming from the soft switch of the originating network. And they want to add a token. So they send a SIP invite to the authentication service. And it sends back this identity header. And it's just a big blob of data that has base 64 encoded data that has that payload that we looked at earlier. And you see this X? I don't know if you can see there's an X. We have to add
of identity.
Yeah, sometimes we have to add that because the SBC won't take a SIP identity header. It's never seen it, block it, you can't add it. So sometimes we have to add an X to enable it to be copied into the outbound invite from the session border controller, and that's what that's all about. But let's just take a look at that token. Let's decoded format, and there it is. That's what we looked at before. So you can see there's the certificate. Here's the attestation value. Here's the call lead number, the calling number, timestamp, and here's the origination ID that we talked about. And this is good. This is a good example. This has this rich call data. It's been added to it. So here you've got a logo example. Here's the website. Here's the name. It could be so. This is the kind of information that can be added to this signed token, and that's the key. It's not just CNAM that's pulled out of some database you're not quite sure about. This has been defined by the calling party, how they want it presented. And you, like I say, you can put in here a reason value. This doesn't have a call reason, and it's signed. And if somebody puts in a bogus picture, a bogus website, a bogus reason for a call, they can be held accountable for that because you can trace it all back by verifying it with this signature. And we think that's super cool. And I think there are going to be bright people that figure out great applications that utilize this trust infrastructure that, we can't think of. And
just in the examples you did show with the 3 phone screens, even that looked pretty good. But yeah, you're quite right. People are going to take that and run with it and come up with all sorts of stuff.
I think so. It always happens. I'm just never smart enough to think of it. But, there are always people that come out of the woodwork. And it's cool. And I can't wait to see what they come up with. But that's as simple as that. I just kind of wanted to give that quick look at it. And so let's just get back. Yeah, sure. And a few Q&A questions that we get. And I thought I'd go through these, David. And you're great at asking questions, but I'll just kind of go through these. These are
you go ahead.
And so question we get, who can sign a phone call? So we talked about at the beginning, you have to be a telephone service provider. And but that hurdle to become an interconnected VoIP provider is not huge. It's not the same as becoming a CLEC. And, we're meeting a number of people. They run call centers. They run different services. They've been non-interconnected VoIP providers, and that's a regulatory term. Everything they're doing VoIP, it's all over the top. They're not officially interconnected with the public telephone network. The steps you have to take to become an interconnected VoIP provider, it takes a while, 4 to 6 months, but it's not a gigantic investment. And you don't have to sign your own telephone numbers. You can sign a telephone number. One of your customers, they bought numbers from, some other DID provider, and they want to use you for outbound calls because you can add rich call data. You can sign those telephone numbers that belong to other carriers. That's allowed by the law. And you're responsible for it, but your customer and you can provide that service. So you just need to have gone through the vetting process with a policy administrator. So that's who can sign calls. You have to get approved by the policy administrator, and it's not a giant burden. Right. So should you do it? Should you outsource shaking or insource it? And there's some providers that say, hey, I'll sign your calls. You buy your DIDs from me, you send them back out to me, I'll sign your calls. And that kind of limits you for least cost routing if you buy telephone numbers from this DID provider, but you want to go out a different provider because he gives you a better termination cost. That provider's not going to sign some other operator's telephone number with an attestation A because he doesn't know anything about that number. He's going to give it a B or C. So if you do it yourself, now you've got full flexibility to give your customers the attestation A, and I think they'll pay for that. And so it's maybe something that, operators are thinking about. So how difficult is it to deploy? It's like configuring a SIP trunk. Everything we talked about was a SIP trunk. You send a SIP invite to an authentication service or verification service, and you get a response on the call treatment. A redirect if it should be rerouted or has information copied into the next invite, or a 603 to block the call. And so it's simple to deploy. And how much does it cost? If it's implemented in, when it's implemented by the open source community, it's just going to be, another module. And so that's going to be affordable. But you will need certificates. And I'm putting in a plug in for what we do. We sell certificates. So 24-hour shaken certificates. We're an approved certificate authority. They cost $3.99 a day, $3.99.
And they rotate daily, do they, Jim?
They do. We'll sell certificates up to a year, but the best practice is a 24-hour certificate, because, if somebody gets your private key, they're not going to go use it to do traffic pumping. They're going to use it. They're going to go off and they're going to take that thing and they're going to hold it for the right time and say, I'm going to create a call that makes me look like David Duffett, and it's going to be signed by the carrier that I stole their private key from, and people are going to think it's really you. So they're going to use it for criminal activity, we think, selectively.
Right.
And, it's not going to happen right away and pump them out. And so if you have a year-long certificate, a bad guy could make, maybe a few hundred high-value criminal calls using your private key. And that's the risk of having a long-lived certificate. But if it's 24 hours and they steal your private key, they can't do much with it for very long. And if they can steal your private key every other day or every day, you got a whole different problem. But
Jim, just a few slides ago, you were talking about accessing a database, and I've forgotten exactly what the context was. But is it only a case of checking that certificate, or are you also checking a database before you give the response?
So
yes, you see the certificate repository.
Yeah.
That the receiving carrier, the shaken verification module will talk to the certificate repository, won't it, to make sure everything's okay?
It gets the public certificate from the certificate repository, and it caches it.
Right. It's okay. I'm with you. So it doesn't have to look at on a per call basis.
Yeah. Now, what a lot of service providers are doing, they are querying for CNAM and their analytics engine on a per call basis.
Right. But what I was trying to get at was that the shaken thing itself does not require subscription, if you like, to a database that happens on a per call basis.
No.
Good. Okay. Because what was in my mind is, you remember the caller ID databases, and carriers, I think, had to pay to access those. And in the end, certain carriers just stopped doing it and would populate the namespace with like the city based on the area code. So you'd get a phone call that says Huntsville rather than saying David Duffett, for example.
Right.
Good. Okay. So that can't happen because it's based only on accessing the certificate once a day.
Exactly. So.
Right. Thanks for clarifying that, Jim.
Yeah, no, that's a good question. I hope I've been clear. And let's see. Let me just get back to the questions and answers, and I think we've gone through all of these. Yeah, that's the last one. Unless, David, you've got some additional questions.
No, you covered everything, and I asked the one that was in my mind there.
Okay. So for folks who are watching, they're saying, I want to get started. What do I do? To get started, it's pretty simple. You go, if you're in the U.S., you have to register with a policy administrator. Anybody can verify calls, but if you want to digitally sign calls, you need to register with a policy administrator. So you go here and follow the instructions to register. To get that service provider code, that's basically a digitally signed token that you use to go get a certificate. And if anybody does that and you want an interop test with us, with your application, we're always happy to interop test with anybody. We'll give you a trial for a million calls, and that should be enough for some decent testing. So,
I think this is the only time, Jim, I've ever seen a free trial that involved 1 million calls.
Yeah, this stuff is easy and not expensive. So that's the good thing about Shaken. And it's going to be big. When you can trust a telephone call and the information about why those people are calling, whoever they are. I don't know, David. We think it's big. We think it's really exciting.
Great. Okay. Well, Jim, thanks very much for taking the time to come and share that. I'm just going to put you back on the full screen so that people can see you and me now. Let's just try that. Here we go. There you go. We're back in the room there. It's great that you've taken time to come and tell us about that. I appreciate you going through that presentation. I often ask this question near the end of a CCW. Is there anything else you'd like to say while we're on?
David, there isn't, except just, again, I want to reiterate, it's great to be talking to you. It's great to be talking to this community, because this is the community that does so much innovation. And like we were talking about this application, I love this application we're using right now. And so it's exciting to just be associated with this group of, this VoIP community of users, because this is so much exciting stuff comes out of this group. Yeah,
indeed. That is one of the great things about working in the community I do, is all the amazing people, the very clever people, and the interesting people that there are in it, with you being one of them, Jim. So thank you very, very much. We'll probably see you at one show or another in the not too distant future. Where are you off to next?
Oh my gosh, it's a lot of traveling this year. I guess the Competitive Communications Association is the rural wireless carriers. And they've got these issues trying to compete against the big guys who've implemented Shaken, and they're interested in how they compete against Verizon, AT&T, and so on. So it's interesting, David. One last thing. This is really interesting. We were at the Rural Telecom Carriers Association last week, and they're pretty aggressive on moving on this, and it's really exciting. It's to see people, these companies in the middle of nowhere. They've got all SIP networks, and all they have is TDM interconnects, but their networks are totally modern and up to date. And it's kind of interesting to see what's going on out there in the world, especially in parts of the world you don't hear about too often.
Yeah, indeed. Okay, well, great. Thank you very much for coming along, Jim. We'll catch you again soon, and we'll look forward to that. But in the meantime, thank you so much for coming on ClueCon Weekly.
Thank you, David.